Welcome to the tutorial on Fit an Exponential Decay Curve. In this tutorial, we will learn to add multiple graph panels to the canvas, remove dataset from the graph panel, and fit a given set of data points with non-linear regression method. To record this tutorial, I am using Ubuntu Linux 16.04 OS, Grace 5.1.25 and gedit 3.18.3. To follow this tutorial, learner must be familiar with the Grace interface. For prerequisite tutorials, please visit this site. Two input files used in this tutorial are provided in the code files link. Please download and extract the files. I have downloaded and saved them on my desktop. I have opened the Grace interface. Click on File Open to open a project. Open the regression.agr project file from the desktop directory. A straight line graph is plotted on this plot window. Let's add another graph panel to the canvas. Go to the Edit menu and select Arrange Graphs option. The Arrange Graphs window opens. Under Matrix, in the Calls drop-down, increase the number of columns to 2. Click on Apply and then click on Close. Notice that one more graph panel is added to the white canvas. Notice that the graph panels are now elongated. I will resize the graph panels to 2 squares as seen on the screen. I will also reposition the legends in the canvas. To select a graph, click on it. The selected graph is highlighted with the black squares on the corners. Select the newly added graph panel. Go to Data, Import as key in the menu. Select the file exponential.txt from desktop directory. Load the data as an XY dataset. Click on OK to plot the graph. Then click on Cancel to close the window. From a visual inspection, the data points follow an exponential decay curve. Double-click on the curve to open the Set Appearance window. Add symbols of your choice and choose No Line. This helps to differentiate the fitted data from the starting dataset. Go to Data and select Transformations. A sub-menu opens with many options for data fitting. Choose Regression from the sub-menu. A new regression dialog box opens. Choose the dataset of interest from Apply to Set. Currently, only a single set is loaded, shown as S0. It is in the graph panel G1 and set is named S0. Choose Exponential for type of fit. This drop-down has few choices with sample functions to do data fitting. In the Load drop-down, choose Fitted Values. For restrictions, choose None. Click on Accept to run the data fitting. The Grace console dialog box opens. Close the dialog box and the generated log file. Notice the fitted data in the graph. Often, the data may follow a complex mathematical equation. Then, we have to define the equation and do a non-linear regression. I will demonstrate it. I will not save the details of the data fitting. I will close the dialog box. Let's delete the fitted dataset loaded on the graph. Go to the Edit menu and open the Set Operations dialog box. In the Source section, select graph G1 as seen. In the Set section, select the set G1S1. Right-click to open the context menu and choose Kill Data. A warning pop-up dialog box opens to confirm the process. Click on OK to kill the dataset. Different types of set operations are possible in this window. I will click on Close to close the dialog box. You may explore further if desired. Notice that the fitted data is removed from the graph. We can also access the context menu from the Set Appearance window. Select the desired dataset from the Select Set form. Right-click to open the context menu and choose Kill Data to remove the data. Click on Close to close the dialog box. I will demonstrate to set up non-linear regression process. For data fitting, select an equation to fit the data. Make an initial guess for the value of the coefficients. Run the data fitting algorithm. Convergence is usually obtained with few iterations. Examine the output parameters for goodness of the fit. Plot the function and data together for visual representation. Go to Data, Transformations and select Nonlinear Curve Fitting. Under the Main tab, we will enter the desired equation. Select 2 for parameters. Two parameters A0 and A1 appear in the form below. I will use an exponential decay curve as seen on the interface. Let's type the equation as seen. There is also an option to input starting values and define bounds. Set iterations to 20 using the black up triangle button as seen on the screen. Set A0 and A1 initial guess. We can make an educated guess for starting values of A0 and A1 from the graph. From the graph, A0 could be around 0.4 to 0.5. Value of A1 is around minus 0.25. Set the initial guess values of the coefficients slightly away. Then the iterative process in the regression algorithm can be observed. Input 0.4 for A0 and minus 0.2 for A1 as initial guess. You may apply bounds checkbox if necessary by clicking on the bounds buttons. In the set section, select the set G1S0. Click on Apply to run the iterations. The algorithm runs. In this window, fitting parameter chi-square is seen. Correlation coefficient RMS, relative error and tail coefficient are also seen. Examine the chi-square values obtained. Low chi-square means the resulting function is a good fit for the data. Residual is the difference between the observed and the fitted values. The sum of squares of residuals is minimized in the least square fitting method. You may note down the values or save the results. Click on File Save option to save the results. A gray Save Logs form appear prompting to give a file name. In the form type fitted values.txt and click on Apply. Click on Close to close the dialog box. Use File Close to close the Grace console window. A curve generated from the data fitting is automatically loaded on the graph. the fitted curve traverse between the given data points. Click on Close to close the nonlinear curve fitting window. Click on File Save to save the project. From the top menu, choose File Exit to exit Grace. Now let's summarize. In this tutorial, we added multiple graph panels in the canvas, learned to delete datasets from a graph panel, and performed nonlinear regression on an exponential decay curve. For assignment, please do the following. Fit the data given in the file assignment1.txt to a parabola. Use an equation of the type as seen here. Fit that given data in the file assignment2.txt to a tan x. Your completed assignment looks similar to this. This video summarizes the spoken tutorial project. Please download and watch it. The Spoken Tutorial Project team conducts workshops and gives certificates. For more details, please write to us. Please post your timed queries in this forum. Spoken Tutorial Project is funded by MHRD, Government of India. This is Rani from IIT Bombay. Thank you for joining.